Good day, sir. So now I will discuss two topics, the area and the volume. So first I will discuss the area. So the learning objective of this topic is to learn and to understand the area of the curve and the volume. Then to master of solving the area of the curve and the method of how to get the volume. So the area has under the curve, between the curve and polar areas. So the principle and concept is that so this is the curve of the graph. So we need to find the area. So if we have the A and the B, so this is the area that we will find, and the dx is in the boundary of A and B. So this is our dx, and our x is here. This is our x, and now the formula to find the differential of areas, the formula is the differential of areas is equals to y dx. Then the integral of dA is equals to the integral of y dx, and the final formula, A is equals to the integral of from A to B y dx. So I will give some examples. So in the example number 1, find the area under the line y is equals to 3x plus 3 from x equals to 0 to x equals to 4. So first, we'll find the area. So our area is in x is equals to 0 to x is equals to 4. So this is our area. X is equals to 0. This is the 0, and x is equals to 6 to 4. So our area is like this. This is our area. This is our y is equals to 3x plus 3, and our area is x is equals to 0 to 4. So this is our area. This is our area, 0 to 4. This is our area. So our dx is in the boundary of 0 to 4. So this is our dx. This is our dx. This is the area. Then our x. This is our x. This is our dx. And the x and y. So for the solvings, for the solvings, dA is equals to y dx. Then a is equals to the integral of 0 to 4 y dx is equals to 0 to 4. Our y is 3x plus 3, so 3x plus 3 dx. Then it is equals to 3x, the integral 3x squared over 2 plus 3x from 0 to 4. So we will put the value in the x. So 3 times 4 over raised to over 2 plus 3 times 4 minus 3 times 0 raised to 2 all over 2 plus 3 times 0. So this will become 0. So we will calculate this one to get our final answer. So calculate 3 times 4 squared over 2 plus 3 times 4. So this is equals to 36. So our final answer is 36 square units. This is our final answer. In example number 2, in our example number 2, find the area under the curve y is equals to square root of x from x is equals to 0 to x is equals to 4. So first, we find our x's. So our x's is 0 and 4. So this is our x's, 0 and 4. Then this is our graph. This is our graph. This is 4. So our graph is this, and this is the area. This is the area, and our dx is in the boundary of 1 and 0 and 4. So our dx is here. This is our dx. So this is our dx, x and y. This is our y is equals to square root of x. So first, we need to create a table of x and y. So this is the table of x and y. So in our x, our x is 0, 1, and 4. And in our y, so in our y, the square root of 0 is 0. So this is 0. The square root of 1 is 1. The square root of 2 Square root of 2. 4. Square root of 4 is 2. So this is 2. So for the solvings, dA is equals to y dx. So the area is equals to the integral from 0 to 4 y dx. Then the integral of 0 to 4 x raised to 1/2, because the square root of x is equals to x raised to 1/2. So x raised to 1/2 dx. Then it is equals to the integral of x raised to 1/2. So the integral of x raised to 1/2 is x raised to 3 over 2 over 3 halves. Then from 0 to 4. So this is equals to negative 2 over 3 times 8, because 4 over 3 over 2 is 8. So this is 8. Then 0 over 3 over 2 is 0. So minus 0. Then our final answer is negative 2/3 times 8. So our final answer is negative 16. So negative 16 over 3 square unit. So this is our final answer. So the example number 3 is find the area at the bounded by y is equals to x squared plus 2x minus 6 and y is equals to 3x. So first we will find our graph. So the y is equals to x squared plus 2x minus 6. This is parabola. So this is negative 6. Then our parabola is this. This is our parabola. This is our parabola. Then our y is equals to 3x is here. So this is our y is equals to 3x. This is our y is equals to x squared plus 2x minus 6. First we need to the intersection point. We need to find our intersection point. So intersection points x squared plus 2x minus 6 is equals to 3x. Then is it equal to x squared plus x squared minus x minus 6. is equals to 0. So this is equals to x minus 3 times x plus 2 is equals to 0. Then our x is equals to 3 and negative 2. So in our parabola, the graph, our x is negative 3, this is negative 3, and this is negative 2. Now we can solve the problem. So solution, a is equals to integral from a to b times the top minus the bottom dx. That is our formula for this problem. So the area is equals to the integral from negative 2 to 3. Our top is 3x, so 3x minus the bottom is x squared plus 2x minus 6 minus x squared plus 2x minus 6 dx. So this is equals to the integral from negative 2 to 3, 3x minus x squared plus 2x minus 6 plus 6 plus 6 plus 6. This is wrong. This is negative. This is negative 2x because negative times positive equals negative. So negative x squared minus 2x plus 6 dx. So this is equals to integral from negative 2 to 3, x squared plus x plus 6 dx. Then it is equals to the integral of this is negative x cubed over 3 plus x squared plus over 2 plus 6x from negative 2 to 3. So this is equals to negative 3 raised to 3 over 3 plus 3 raised to 2 over 2 plus 6 times 3. 6 times 3. Then minus negative 2 cube over 3 plus negative 2 raised to 2 over 2 plus 6 times negative 2. So this is equals to negative 27 over 3 plus 9 over 2 plus 18 minus 8 over 3 plus 4 over 2 minus 12. So, our final answer, we'll use calculator for this. So, we will use calculator. Negative 27 over 3 plus 9 over 2 plus 18 minus 8 over 3 plus 4 over 2 minus 12 so our final answer is 125 over 6. So this is our final answer. So in our example number 4, this is in polar areas. So example number 4, find the area of the region inside the limacon r equals to 4 plus 3 cosine theta. So this is our graph. Then this is the area of our graph. So we can cut our curve into half. So we can use 0 and square and a pi. So for the solving, the formula is a is equals to the integral from a to b 1/2 the f of theta squared d theta. So that is our formula for this problem. So it is equals to a is equals to the integral of 0 to pi 1/2. Then our function theta is 4 plus 3 cosine theta squared d theta. So it is equals to the integral of 0 to pi 16 plus 24 cosine theta plus 9 cosine squared theta d theta. So the antiderivative is 16 theta plus 24 sine theta from 0 to pi plus the integral of 0 to pi 9 cosine squared theta d theta. So the half angle formula of cosine square theta is equals to 1/2 times 1 plus cosine 2 theta. So This is equals to 16 pi plus 24 sine pi minus 16 times 0 plus 24 sine theta. So 24 sine pi is equals to 0. 16 times 0 is equals to 0. 24 sine theta is equals to 0. So this is equals to 16 pi. So 16 pi. So this is equals to 16 pi plus the integral of 0 to pi 9 cosine squared theta d theta. So we will solve this. This is equals to the integral from 0 to pi. The cosine squared theta is 1/2 times 1 plus cosine 2 theta. So 1/2 times 1 plus cosine 2 theta d theta. So this equals to there is a 9 here, I forgot. So this is equals to 9 over 2 integral of 0 to pi 1 plus cosine 2 theta d theta. So this is equals to 9 over 2 integral of 0 to pi wait, no, this is wrong. So this equals to 9 over 2 theta plus 1/2 sine the integral. So 1/2 sine 2 theta from 0 to pi. So this is equals to 9 over 2 pi plus 1/2 sine 2 pi minus 0 plus 1/2 sine 2 times 0. So sine 2 pi is equals to 0. 0 plus 1/2 sine 2 times 0 is equals to 0. So this is equals to, this equals to 9 pi over 2, then bring down the 16 pi. So 16 pi plus 9 pi over 2. Then this is equals to 32 pi over 2 plus 9 pi over 2. And our final answer is 41 pi over 2. So this is our final answer. Next topic is the volume. So our learning objective is to learn and understand the topic, then to master the technique of using the washer method, disk method, and shell method. So the principle and concept. So first, in the disk method, so this in this graph, this is our y is equals to f of x. Then this is our dx. This is our dx. This is the measure of our x. And this is the measure of our y. So, and this is the area. This is the area. So, in this method, this is the graph. This is our graph. This is our graph. Then in the x-axis we have AOR. So the formula in this method is v is equals to the integral of from a to b pi y squared dx. Then in the shell method, this is our graph. This is the y is equals to f of x. This is our area. This is our area. And this is our dx. This is the measure of our x. This is the measure of our x. And the measure of y. So in this graph, we have a cylinder. We have a cylinder in our graph. And our AOR is in y-axis. So the formula for this method is v is equals to the integral of from a to b 2 pi xy dx. So this is the formula. And from the washer method, this is our graph. This is the area. This is the area. And the dx is in the boundary of the area. So this is our dx. And the measure of our x is from dx to 0, the measure of our x, and this is the measure of our y. So the formula for the washer method is this: v is equals to the integral from a to b pi b squared minus b minus y squared dx. So this is not the real formula for the washer method, because this is the representation of the volume from this problem. So for the example for this topic is find the volume of y1 that is equals to x squared and y2 that is equals to square root of x. So our graph is this, from 0 to 1, our y1 is this, is a parabola, and our y2 is this. Our y2 is is 1 to 1. Then the diagram of our graph is this washer. This is a washer method. This is our graph. So the y1 the y1 measure is from here to here. This is y1, and the y2 measure is from the top to the middle. So this is the y2 measure. Then the AOR is from the x-axis. So this is the diagram. Our dx is our dx. Our dx is this. This is our dx. This is our dx. So the formula for this is dv. This equals to pi y squared 2 dx minus base of 2 dx minus pi y squared 1 y1 squared dx. So v is equals to the integral from 0 to 1 pi, then y2 squared minus y1 squared dx. So this is equals to the integral from 0 to 1, the square the pi times the y squared is square root of x. So this is x minus x to the fourth, because the y1 is x squared, so y to the fourth, and dx. So we will calculate this. If you calculate this, the integral from 0 to 1 pi times x, here's the x minus x to the fourth dx. So we get the final answer from this problem. If you calculate this, so v is equals to pi over 1/2 minus 1/8. The final answer is 3/10 pi cubic unit. So this is our final answer.